All right, so this is the block that we've titled Visual Systems. We have 5 awesome talks for you, which all involve very loosely some aspect of live programming with pictures. And our first speaker today is Marcel Goethals with Subsequently.
So hello everybody, my name is Marcel Goethals. I am a researcher at Ink&Switch. I work on a project called Programmable Ink, which I will not be telling you about today. My colleagues Ivan and Alex will be telling you about that in an upcoming presentation. I'm going to talk today about a project I've been working on called Subsequently, which is a visual and tangible programming environment for exploring and understanding algorithms. So one of the questions that I'm interested in is like, how do we build mental models of programs, right? Like, how do we get an intuitive understanding of what an algorithm does, how it works? And one way of approaching this is to look at how people explain algorithms, right? So here's somebody that's like trying to explain an insertion sort algorithm, and what they, like a kind of pattern that you see again and again is what people will do is they'll do a step-by-step walkthrough using a concrete example, right? So they're like drawing like actual data structures on a piece of paper. They're like walking you through step by step, sort of telling a story of what's happening in the program. And what's interesting to me about that is that it's so unlike the experience of actually programming, right? When you're doing an explanation, you're using concrete examples to tell a story, and you're using pictures to sort of support your story, your narrative that you're telling. When you're programming, when you're actually implementing an algorithm, you're dealing with these abstract generalizations, you're sort of pushing around these abstract symbols on the screen, and you're certainly not having any pictures that like kind of support what you're doing. So the question is, can you tell stories with pictures to make programs, right? Can we try and make the experience of programming a bit more like the experience of when you're trying to explain something? So here's Subsequently. Oh, it's like only partially on the screen. I can see now. That's okay. We'll deal with it. And so, oh, there we go. Great. Yeah. So what we're seeing here is in the beginning, you're sort of prompted with this panel in the middle of the screen, and it says in the beginning, as you can see. And so it's telling me, okay, begin to tell your story, right? So I can drag this thing over here into the middle. And what I'm doing is like saying, okay, let's create a list. And the description on top will be updated, right? Create a list A. And I can continue my story, right? I'll create a panel underneath and saying, okay, and then what do we do now? So what I might do is sort of concretely act on that data structure, right? I'll take this number over here and drop it down. And you can see, again, the description updates, right? Take the last element of A and call it B. And these things are color-coded, right? So like A is green and B is blue, as you can see. Now you might, in this case, I'm sort of taking the last element, right? But I might want to do something else. Maybe I'm like interested in taking the second number, right? So I can do that as well. In this case, take the second element of A, right? Or if I really wanted to do, I can do something even more fancy, right? Maybe I'll like add a second number over here, and then I'll concretely act on that number over here, and then say, actually, it's not the second number, it's the bth number, right? I'm like using that number over there to like index into the array. And indeed, if I scrub this number over here, right, you can see that it updates. You see that, right? So this is sort of the general principle of the system, right? I'm sort of like creating these sort of concrete steps, directly manipulating data structures, and in doing so, building up an execution of a program. So let's try and do something a little bit more interesting here. So maybe I'm going to create a program that reverses a list. It's a very simple program, right? So I'll create a list first, then I'll create a second list that I'm going to use as sort of the target where I'm going to put my reversed list into. So I'll create an empty list, right? Again, the description updates. And then what I'll do is I'll like take the last element like this and like pop it into that element over there, right? And I can continue doing this if I wanted to, right? I could just concretely act on the data and like, right? This is a bit of a simple program, right? We're programmers and we want to like actually automate this process. So let's try and do that instead. So what I can do here is I can take these eyes, right? And I can drop them on this list, right? And so these eyes are looking into the array and saying, is this an empty list? No, it's not. And as you can see under here, we sort of created a branch-like structure that's appeared, right? And I can sort of click on these to create panels for each of them. And as you can see, one of the branches is highlighted and the other one is grayed out, right? Because we're concretely running this program, and this branch, we don't have any, it's just not occurring in our program. So in this case, what we want to do is, okay, if the list isn't empty yet, we'll just like take the last element, put it in the second list, and then what I'll do is I want to repeat that process, right? So I'll just concretely draw an arrow up and like wire it up like that. And now what you see happened is there's these little dots that appeared, right? Which are sort of indicating that like the program is looping around, and like every time it passes around, there's a little dot. So if I click on those little dots, I can actually see the execution of the program step through, right? Until eventually, inevitably, the list is empty. It'll say, yes, it's empty. And if we look down there, we can see, indeed, the list has been reversed. Success. Okay, let's try something a little bit more interesting, right? Let's try filtering a list. So we want the list. Let's do this. Like that. And I'll create a number as well, which I'm going to use as my condition, kind of, right? So I'll say, let's give me the list in order, but like only the numbers that are smaller than 4. So we'll do the same thing again. I'll drop in like the eyes. And now in this case, what I'm going to do is take the first element, right? So I'll concretely take out the first element, drop it next to it so I can compare them. And I'll take this comparison action, right? I'll put that underneath so I can say, so I'm going to compare 1 and 4. And indeed, 1 is smaller than 4. So we can see, indeed, if we do this, right? Yes, 1 is smaller than 4. And so what we want to do if it is smaller than 4 is we'll drag the 1 out and like append it to the list like before. Okay, and then we just want to repeat that process, right? So we'll like drag it up again all the way to the beginning. There we go. Interesting, right? Because there's now only 4 iterations that appeared. That's a little bit strange. Zoom out a bit, I can check. And indeed, we'll see, when we switch to the 4th iteration, we've reached a branch that we're not doing anything with yet. So in this case, 4 is not smaller than 4. It's equal to 4. And we just want to like continue and do nothing with that value. Oh dear. Going to drag it all the way up. And now, the program continues. Right, and so if I can sort of toggle between these things, you can see all of the different code paths that the program takes, and in the end, we'll see the result, right? We filtered the list, so we only have the numbers smaller than 4. And again, this is live, right? So if I update this number, it'll dynamically recompute. Okay, cool, let's go back to the slides. So what do we see here? This is sort of a truly visual programming language, right? And we're visualizing 3 things in particular. We're visualizing what is happening, and what will happen next, right? So we're visualizing what is. The state of the program at each point in time is there in front of you on the screen. But not only that, we're also visualizing what is happening, right? Because programs aren't just, arbitrary sequences of state. Things happen for a reason. And so we're trying to visualize those reasons. Right? Before and after pictures, if I'd just done that, they don't encode causality. What happened here? We don't know, right? It's sort of too ambiguous. And so just before and after pictures aren't enough to encode real reasons. So instead, we make movement visible, right? And we use this sort of like effective visual language, right? It's not just like appending a thing to a list. No, snap, right? It's like actually clicking together. And this is not necessarily an original idea, right? Like comics have done this for ages, right? They use sequences of images, but they also encode like motion using visual language. Now, just because we've done that doesn't mean it's completely unambiguous what is happening, right? Because we're creating programs, and there's sort of different levels of abstraction that I might mean by dragging an element out of the list here. So it might mean that I'm taking the 3rd element concretely, or it might mean that I take the last element, right, and it doesn't really matter how long the list is. Or maybe I'm doing something even more abstract, like taking the nth number of the list. And so the solution here is that I'm just sort of like doing this disambiguation through structured interactions, right? So in this case, if like the user pulls out from the side, that means it's like the last element. If I'm pulling down, that means like concretely that I'm using a specific index. And as we saw in the demo, right, I can also even wire up that number and say, no, actually, this is a number that I'm using from the program. I'm also using these descriptions, right, which is important. So it's not just the visual or the text, it's the visual and the text together that like help, clarify what's actually happening at each step. And finally, what I'm making visual is like what will happen next, right? So I'm using this sort of visual flow diagram style arrows that show control flow. And we're also flattening time in space. So just like I'm visualizing actions and making them static on the screen, I'm also saying, well, actually the entire execution of your program is like there in front of you, right? I'm sort of like the beginning, the middle, the end, it's all there right in front of you. So runtime versus compile time, no thank you. Step debugging, out of the window, right? We don't need that. If you want to know what's happening at a certain point in time, just go and look. It's right there. Now, this is obviously a very early prototype. There's lots of different things that still need to be explored. But I hope at least I've convinced you a little bit that you can tell stories with pictures to make programs. Thank you.